Good evening to all my distinguished listeners. We have uploaded a video just now, and this is part 2 of this trial video. My purpose is to share my knowledge being an engineer administrator as well as a researcher of both law, management as well as engineering, and an experienced administrator of the country both in terms of the law of the land and international law, and also having experience working in the best private sector industry in the country, namely the Tatas, in Tata Motors, way back almost 3 decades ago. We have covered the necessity of engineering students appreciating the importance of engineering process design and how the R&D work, research and development work, goes together in the quest of excellence for any industry. Today, the slogan in the entire country is towards Make in India, Best in India, and we are now, I'm happy to share with you that we have just crossed France as the highest GDP nation in the world. We have only 4 more to cover to become number 1 in the country. Maybe in few days or few months, we will cross Germany, England, and ultimately Japan. And our ultimate competitors will be the ABC, America, Bharat, and China. And I hope by 2047 we will be numero uno in the world, both as a consumer and more than that as a producer. The engineers of the country with the best brains, the Satya Nadella at the Microsoft and Sundar Pichai at the Google, is an indication, and this is the morning, as morning shows the day. I have every reason to believe that my brothers and sisters among engineers of the country, as they have always done proud, will definitely continue to do proud, so that I will see in India in 2047 to be the giant in engineering, manufacturing, design, research, development, and the best in terms of innovation, efficiency, effectiveness, and solving people's problems, and to make what Phillips Kotler always says, the delightment of the customer and the consumer. Now, we have just covered what is the importance of engineering process design. We must understand that engineering process design caters to either a new product in an innovative manner or improvement of an existing product or a process. We must also understand that it's basically 3 P's. First P is the product, second P is the process. Many of us may not have heard of the third P. I would like to add the third P, that is the plant. A plant is a product, is a combination of both. It's a product as well as a process. In other words, when we say goods and services in terms of the GST, the goods and services tax talk, goods and services, goods is the product and services are the processes. And where we produce both of them is like a manufacturing plant, wherein you produce a product and you offer also services. For example, a fan or an AC, air conditioner, you sell it and you also maintain a customer relationship management kind of relationship with those customers, so that his needs of the continuous quality assurance of the product is taken care by your continuous services offered to him. So it's a plant, it's a process, and it's a product. So these 3 things are important. And now engineering process design is there everywhere. It is there in this pencil, it is there in this room, it is there in a toy, it is there in a submarine, it is there in an intercontinental ballistic missile, it is also there in a spaceship. And if you don't take care of the micro aspects of it, then it will cause accidents, as it happened with Columbia shuttle explosion. when we lost one of our brightest Indian girl, Miss Chawla, way back 2 decades ago. I learned a thing in Tata Motors way back in 1980s when I was working there. When I entered the Tata Motors plant, in those days it used to be called as Telco, Tata Electrical Locomotive Company, Jamshedpur. The big slogan used to be there when I entered the plant. That is, here we pay major attention to minor details. Here, I repeat, here we pay major attention to minor details. The major attention part is towards the minor details part, because the minor details only may cause a major problem. When we produce a product, there may be 10,000 smaller products. When an aircraft flies in the air, there is nobody. If it goes under repair, there is nobody to go and repair it. It's not like a cycle shop or a car, wherein if the car doesn't function, you take it to a garage. There's no garage in the middle. There's an explosion. It's life and death. So you have to have systems wherein if an engine falls or if there is a failure of one part, other parts. But 10,000 millions of parts are there, and much more so if you are sending people to space to other. So, for example, mission Mars. If you want to send a person as a human being to another planet, whether he comes back or not, whether he or she comes back or not, this system process design must take care of that. Fortunately, we are having now systems which can take care of this aspect. Now, when we talk about a plant, P, process and product and plant. In a plant, we have power plant, for instance. Power plant is a big plant wherein there are products, there are processes. So is the case of, say, for example, a fertilizer plant or a plant like our cement plant. We all are aware in 1984 there is a big explosion, methyl cyanide in Bhopal, which led to thousands of deaths. And this again is the biggest safety issue. To continue this, I would like to show this diagram to you. I just made a diagram. This is the diagram. I would like to explain to you here. Please zoom in the camera. See here, this cycle follows this. If I draw a graph between time on the x-axis and production cost on the y-axis with percentages 20, 40, 50, 60, 80 and 100. And if I say cost incurred, and if I create a graph of the process of production cycle from the design process to manufacturing process, production line. Here I start the design process, then the marketing is done for the process, then of course the conceptual is developed, and then the product is manufactured, and manufacturing product design is made, then production is done, and then production is used for sending of the product. This is the cost. So we have got a production design process wherein we have the cost committed and the cost incurred. Both will merge here at this point. This is the last point of the graph, wherein the 100% of the cost and 100% of the timeline. This process is called the production, is called this product cycle, which you talk when the cost incurred and the cost committed both coincide with this, both in terms of cost, the y-axis, the production cost, and x-axis timeline. We must also understand, if time is extended, you are always beaten by your competitor. You do not work in a vacuum, even if you are a public sector, in any so-called protected economy. And in the days, in the current days, there is nothing called protected economy or protected economies or protection cycles, because the collapse of the Soviet Union, we understand that even public sector also had to compete to stay back, because quality and customer is the king, as they say by the marketer, the professor, the marketing guru, Professor Phillips Kotler. Now, design normally costs around 5% only. Here if you come manufacturing, I always say M3. M3 means not muscle, man and material. Here M3 means money, manpower and materials. Money for both intellectual labor as well as non-intellectual labor in terms of production workers those who are required for that. Now, Phillips Kotler said customer is the king. Unless you anticipate the customer needs, unless you are slightly ahead of the market, and Phillips Kotler rightly points out, future has already happened. Future is not there in the future trends. Future has happened. One has to anticipate the customer needs, delight the customer, so that the customer will stay back to you instead of shifting to your competitor. Michael Porter, whom I consider as my own guru in terms of strategy, I way back when I studied MBA from IIM Calcutta, strategic management was an important subject even nowadays. Michael Porter is an authority. He teaches at Harvard strategic management. He takes care of, he always emphasizes three things: differentiation, cost, and leadership of the production. So if you want to stay back in the market, you have to take care of these three aspects. So production cycle time is an important thing, because production time overruns will always impinge on cost overruns. And if you lose on the cost, you are losing the competition, because cost means 33 or more than 33% of this. Differentiation, of course, is there in the innovation part of it, the design part. The cost is one that makes your product slightly less costlier, but more quality-wise more. Then only the customer will come to you. Customer goes by the logic, not by your advertisement. Let me share with you one more slogan of mine. I always maintain the 24-karat gold doesn't require a public relations officer. The quality speaks. The customer knows. The customer is the king. So I combine here both Phillips Kotler and Michael Porter when I say customer knows, customer is the king, and customer is quality conscious. And hence we have to be quality conscious. And it must be there in the production side. Let me end this small video, 10 minutes, by saying that there are 5 types of designs. One is, of course, the innovative design. The second one is adoptive design. The third one is the redesign process. The fourth one is the selective design. And the fifth one is industrial design. The first one is the most important thing, innovative design. The most important design which are innovative products. For example, cell phone is an innovative product. 5G is innovation. Cool automatic Tesla is an innovation. Driverless vehicles. Electric car is an innovation. Solar energy is an innovation. These kind of epoch-making incidents happen and they change. For example, when the digital cameras came, nobody is going for any other cameras. Now today camera sales have come down because everyone is a cameraman with 5 MP, 16 MP, 13 MP cameras in cell phones. Adaptive design is the one which adapts to situation improvement. Existing thing is there, you improve upon it to make a micro change. For example, delta X, X plus delta X, or X plus delta X twice, X plus delta X thrice, like that. You make delta X part of it. Bring it innovativeness. It's like Kaizen, constant improvement. Japanese concept of Kaizen. Third one is redesign. Products are available. Pumps are there in a machine. You somehow redesign the process in a combination. Existing small products, you make assemblies in a manner that you come out with a new redesign process. A new product will come. Basically, the components are there. You link these components one after one, and you come out with a new combination which will be serving a new purpose, which was hitherto unexpected. So it's a combination of existing things. So in other words, you have got all those things already there in front of you. You redesign your process in assembling them to invent a new production purpose out of it. The fourth one is, of course, selective design, wherein you choose a selective process among the existing things and you fit in to your process. Industrial design is, of course, there, wherein you have got particular need of your industrial particular product and you order for a specific design for that. So let me end my interaction with you today for this, and tomorrow we'll take up a new aspect of this. Thank you. Jai Hind. Vande Mataram. Jai Chandrasekhara.